Hi, it's me, Brandon again. So in this video, I'll be talking about GDB. So GDB stands for GNU Debugger, where GNU is an acronym that's GNU. And GNU is another topic for another day, but as it happens, GCC, the compiler we use, stands for GNU C compiler in historical sense, or nowadays GNU compiler collection because they've added a ton of more compilers besides C. Anyway, we can talk about that another day. Let's look at GDB. So right here, I have a directory with just plain Jane C files and a makefile. For the time being, I won't be using that makefile because I want to show you how you use GCC with debugging. So first off, let's look at these C files that we have. So I have my main.c. It's just a simple C file. I have some functions defined. You have function bar that calls foo, and then you have our main. You have some variables, calls the bar and foo. We also have up here an extern function so it looks for this particular function in another file. In this case, this function exists in that ext.c file. And we have this big for loop that runs 5,000 times, and we return 0. So in our ext.c file, we have the function extfunc actually defined, and because that function declaration or function prototype was extern, it'll look for it over here, or look for it wherever it ends up getting defined. Anyway, so first we want to compile our program, and in order to debug efficiently, we'll have to use a new flag. It's called -g. So you can see it here. GCC -g. Got to compile our main and our ext.c because that's where that extra function is defined. So let's see. Bam. So we've got our a.out file. So there I just typed in a raw GCC command. Whenever you guys are using makefiles, you want to go to your makefile and set a C flag for that. So here we have the -g, my C flags. So your makefiles might be structured differently. They might have the entire GCC command right there, but me, I like to keep my C flags separately. You can see here that I actually have like a debug target, so I could just do make test to run GDB with it. But let's actually get into running GDB. So the command to run GDB is, well, GDB, and for right now let's just try running GDB without any arguments. So you can see here that we just started GDB without any arguments. It has no files open. So to fix that, let's open that a.out file. So file a.out, enter. So now it's set up from a.out. So you see the thing reading symbols from a.out done. So when you use that -g parameter, it's telling our C compiler to build it with debugging symbols, and these symbols basically give it the execute information about line numbers, variables, and their types and whatnot. And that will help GDB, and GDB can read that and then actually have an idea where lines are. Otherwise, you have to debug with like raw assembly instructions, because there's no notion of a line of code. Anyway, so you can see that we've loaded this, but if you want to make your GDB command a lot nicer, you can actually open GDB a.out or whatever your executable name is. So there we go. You just do it in one go. Right, so at the beginning, the program isn't actually running. So let's run it, right? Wrong. So right after running it, it'll just go ahead and run the entire program. It won't stop anywhere. So to fix that, we want to set a breakpoint. So to set a breakpoint, you press B for breakpoint. Intuitive, isn't it? So you can breakpoint at like a line number like 1, 2, 3, 4, or you can breakpoint at a specific file at a specific line like main.c : and then specify line number, so like 1, 2, 3, 4, or whatever. or we can provide it a function like main, which is a function. So let's set a breakpoint at main for right now. So we have our breakpoint set. You want to run this program, so you press R to run. Yeah, very intuitive. So we're running. It started the program, and now it breakpointed at main. So if we want to resume the execution from here, we would press C. But we have no more breakpoint set, and it'll just keep running until the end of the program. So for now, let's ignore C. I'll be using it later. So we have two commands to do stepping. You can use S to do a step, or you can use N to do a next line. And the difference is that S will step into functions whenever it encounters a function call, and that's hence S for stepping in. And N is for next line, which means that it will end up stepping over the functions and basically just running all that function and then going to the next line and stopping there. So a cool thing about S and N is that you can actually give them a number after them to tell it to do this, to tell this to step 10 times, or next line 10 times. Alright, so let's step, shall we? So let's see. I'm gonna do next line. So here we're at this line where they're declaring and setting a variable called string. Now they're setting a variable called local here, and now they're setting a pointer here. So what is really cool about GDB is that you can print the values from the command line. So the command to print is P for print. So you can print basically any variable you want, or expression actually. So I do P string. You see it knows the pointer, it knows the address of it here, and it can actually understand the fact that it's a char pointer, so it's probably a string, null terminated string, so it also prints out the string there. So we can print that in called local 10. You can format into hex actually, so sorry, px, what's it? Okay. Anyway, so you can actually print it in hex. I can't remember it off the top of my head right now, but something along the lines with the letter X in it. I remember that much. We can also print our local pointer, and it'll give us our address here. And I happen to have built this using a 64-bit machine, so that's a 64-bit address. We can dereference local pointer. We can use print with, say, expression like local plus 10, and it'll print local plus 10. But it doesn't actually change the value of local. You can see when we print local, it's 10 again. Or it's still 10, rather. Anyway, so let's try entering some functions. Right now we're sitting on a call to bar, so let's press S to step in. And now we're inside bar, as you can see, bar at main.c line 12. And let's go deeper. So this is a function called a foo, and it passes in 10. So this function takes in a variable called arg as one of its parameters, and we can actually use print on our parameters as well. So basically, if it has a symbol associated with it, like a global variable, a local variable, or an argument variable, or parameter variable, you can print it. Anyway, so now that we are inside all these function calls, you probably are wondering, hey, can I access the local variables of, say, main before it called bar, or bar before it called foo? And you can do that. So if you guys remember from 319K, we talked about stack frames and how the call history of all these functions is basically stored on a stack whenever you have to save your registers and save your link register and whatnot. Same thing still happens here. So let's try that. We can print out the stack trace using BT for backtrace. As you can see here, we're sitting currently at 0, and we're in foo. Above us, bar called us, and main called bar, who called us foo. What I personally use is where, because it feels a bit more intuitive to me, like where we are right now. And it does the same thing. So that number is the stack frame number, and we can use that to navigate between different stack frames. Like let's go to bar. So now we're looking at frame 1, which is bar, who called foo. We can go even further and go back to main. So now we're seeing in the context of main, and we have access to our beautiful local variables like local and p, local pointer. Cool, isn't it? So yeah. So I think now that this is some basic usage, we can go into a bit more advanced usage of breakpoints. So let's actually set a breakpoint in another file. So let's break into x.c at line 3. And yep, we set a breakpoint there. And let's finally press C to continue and let it run until we hit x.c. As you can see here, we just broke into xfunc at this line, setting this variable to 5. So cool. Anyway, let's get back to main. Alright, so now we're back in main. We have our local, and it looks like we're incrementing local by 10, so let's do that. So if you're like me, I can't remember exactly the line numbers of every single bit of code I wrote. So fortunately, GDB provides us a nice little command called list. So we can list the code with L. We can list the code around a certain line number, like let's say list around 5. It'll give a listing of code around 5, as you can see. So let's do a normal list right now. Cool. Alright, so looks like we're sitting around line 24. Let's look what's around us. So you can see here we have this giant, or not really giant for loop, but a for loop that runs for 5,000 iterations. You might be wondering, maybe I want to set a breakpoint whenever we're on the 2345th iteration. And we can totally do that. So let's set a breakpoint at where we do the printf at line 27. And we can provide the breakpointing with if statements to do a conditional breakpoint. So break 27 if I equals 200 or 2345. As you can see, it's perfectly valid. It'll set a breakpoint there. All we have to do now is press C for continue and let it run until it's 2345. As you can see, we breakpointed when I is indeed 2345. So let's print I. Yep, there it is. Alright, we can still do some more stuff. Like, let's say we've set, I don't know, 23 breakpoints, and we can't keep all these breakpoints in our head. So we can actually print out our list of breakpoints with info break. And here it gives us the listing of our breakpoints and how many times they were hit. As you can see here with our third breakpoint, it stops only if I is equal to 2345, which was our conditional breakpoint. You can see where the breakpoints were, their addresses, yeah. So we can actually delete breakpoints using D, and since we info breaked, we can see the number for each breakpoint. So let's delete that third one that we were sitting on right now. Let's info break again to see that it's deleted. And besides the really permanent delete, you can actually disable and re-enable the breakpoints. So to disable, you type in disable. So let's disable the second breakpoint. So disable 2. Let's info break. You can see under this line or this column here, E and B for enable, that breakpoint 2 has now been disabled, or it's enabled as no. So let's re-enable it, and all you have to do is enable 2. Info break. As you can see, it's enabled again. Alright, so this is all fine and dandy. But you might be wondering, is there a way for me to see the source code while I debug? And the answer is yes. So let's quit. You can see here that the process is still running, so you know, let's just continue until it's done. So you can see here that it's done, it's run all those iterations, and then it exited normally, which is cool. So quit. So you can pass GDB parameter called TUI, and that means it'll use terminal UI and give you a nice interface in it. And let's open a.out with it. As you can see here, we get this magical little window, terminal window thingy that shows us our code. And right now, the focus is set on it, so if I press the arrow keys, I can navigate the code. I believe you can also use page up and down. No, you can't. Anyway, so you can navigate the code here, and now that this window has focus, you can't use the arrow keys to like go through the command history, so you still have control over entering commands at this line down here, or this prompt down here. So I do focus CMD for command. Now you can see that focus is now set on command window, and I can use my arrow keys to go through my history of commands when my history is just that focus command. And to focus back on that window up there, you do focus source or SRC. Yep, here you go. So as you can see here, we can see the code, we can see our line number, so let's put a breakpoint at like, I don't know, where they set local plus equals 10. Let's do that, that's line 23. As you can see here, when I set that breakpoint, we get this nice little B plus there, telling us that we had a breakpoint. So let's try deleting it, D23. Oh, sorry, well, I forgot. Delete uses breakpoint numbers, so that was breakpoint 1. And let's see. It doesn't automatically refresh the screen, but as you can see there, it just refreshed it after I moved the window up and down. Well, this is actually basically most of the most common GDB commands. You can go ahead and look up more commands on the internet. I think I covered most of them in this video. So it's basically the end of the material I'm giving on GDB. I'll be talking more about symbol table, or that debug symbol table, after this, but you can feel free and stop watching now. Anyway, so about debug symbol tables, you might be wondering why we don't just build programs with the symbol table all the time. And the thing is that that symbol table takes up space in the executable, and how much space really depends. If you have a really small program like this, that symbol table is pretty much inconsequential. But as your code gets bigger and bigger and bigger, you have more variables and whatnot, that can end up having a pretty significant size. So I actually have here in a different directory, it's in shell. I've already compiled a version that didn't have the -g and one that does have the -g. You can see here that I have this NSH, which is an executable, and NSH-G. So -G is for the debug version, so I can actually ls and then print out the size in the human readable format. So S for size, H for human readable. And I'm just gonna do it for things that start with NSH and then use a wildcard to capture anything that goes after NSH. So let's look at our executables. You can see here that the one without debugging symbols was only 20 kilobytes, but the one with debugging symbols was 28 kilobytes. So you have 8 kilobytes of data just to hold the debug symbol table. And my C files aren't exactly that big either. So if we do a blank word count on nsh.c, that's only like 400 2 lines of code. As you can see, those symbols can really increase in size. So ideally what you do is you present your release without debug symbols, but you do all your debugging with an internal build that has the debug symbols. Anyway, so that's all I have to say. Good luck on project 1. Good night.